Hey everyone, continuing with the disk method and shell method, I'll be showing you some examples on how we can apply both the disk method and the shell method. So let's consider this very familiar graph again. Let's say the EX graph, right? But for simplicity, I'll just showcase the positive region, positive X region. So we just ignore the negative X region. So this is Y equals to EX for X bigger than 0. All right. So let's say the question is the region bound, I'm going to use like some short form, bound by curve x-axis lines x equals to 1 and x equals to 4 are, sorry, is rotated about the, is rotated 2 pi about the y-axis. Find the volume. Okay, so this is the first part. Second part is everything's the same, just that it is now about x-axis. Find volume. All right, fantastic. Okay, so first of all, this is one way to put it. Now way they can put it is they just straight away show you where the region is. But nonetheless, let's start. We know that x equals to 1 is right here. This is just a guess. X equals to 4 is somewhere around here. Regardless, the region is above the x-axis, so it doesn't matter. The region is just right down here, so we just label this region as R. So the first thing first is, let's draw lines before we actually start with our choosing of method. So you notice that all the lines in the area are perfectly touching the x-axis. So there'll be no lines that are that will straight outwards, so there'll be no line something like this. So we are all fine. So it's straight downwards to the x-axis. So the first part is saying that, well, the regions are rotated about the y-axis. All right, so we know that the lines are vertical, the axis is also vertical, therefore this would be the shell method. All right, now we look at part 2. We now rotated about the x-axis. So when we rotate about the x-axis, the lines in the region are now perpendicular to the x-axis, and therefore this would be the disk method. Okay, now that we got the method right, that's time to find the volume. So for the first part, all right, it will be 2 pi xy dy. All right, so a very easy way to figure out what the variable we are integrating with respect to is to find the width of one of the disk or one of the shell. So over here, we notice that, okay, our shells are delta x. So it will be dx. So very simple, it will be 1 to 4. All right, because we are looking at x equals to 1 to x equals to 4. So we just perform our integration. We substitute in our function y equals to ex to get us 2 pi limits 1 4 x ex dx. Then we realize that we do integration by parts, right? Our integration by parts. So we get 2 pi. Now I integrate ex first. I get back x ex. I'm putting my limits for 1 minus away. Now I differentiate the other. So I differentiate x to give me ex. Again, putting my limits and adding my 2 pi, because this 2 pi is actually like this, but I split them out together. Integrating ex dx. Okay, now I get 2 pi. You can just sub in the values here if you want to. So over here, if I want to sub it in, it's basically 4e power 4 minus e minus away 2 pi ex for 1. Now I try to simplify as much as possible. So I solve, put in the limits for the second part of the integral. So I get 2 pi e power 4 minus e. Now I simplify, I'll get 6 pi e power 4. And obviously adding your units cubed. Okay, so this will be the volume where we rotate the region R 2 pi about the y-axis through the shell method. All right. Now the next method for the next part would be the disk method, because we are now rotating the region about the x-axis, and the lines drawn in the region are perpendicular to the x-axis, and therefore the disk method. So again, pi y square dx. Okay, again, if you cannot remember what the formula is, draw the disk. All right, so this looks more like a muffin. Yeah. Okay, so your width is delta x, so dx. Your radius would be y, right? So if you just notice, just imagine your disk is right down here, y. But it's obviously becomes vertical, right? Because your disk is actually like this, right? So delta x here would be y. Okay, so obviously the area is pi r square, so your radius is y. So pi r square, then delta x. Whatever it is, now we solve. So we get pi, integrating, substitute y equals to ex inside. I'll get e 2x, forgetting my limits, 1, 4, 1, 4 dx. This should be quite simple. Pi e power 2x over 2, you can put a half outside, but if you leave it in, it's fine. 1, 4 equals to pi over 2 e power 8 minus away e square. Then you can simplify to give you e square pi over 2 bracket e6 minus 1, and obviously adding your units cube. So yeah, if you notice, the volumes of each of the regions or each of the revolutions are different because we are rotating the region in the different axes, right? One is about the y-axis, one is about the x-axis, so the volumes will inherently be different. So yeah, there we have it, the first application of your disk and shell method, where we decide which method to use based on the line that we draw.